My name is Jose, and joining with Sri, I'll be talking about Aruba AIOps, the cloud advantage. Just to set context and just reiterate things that Michael talked about, we have three main pillars to enable AIOps. One is the unified infrastructure that includes campus, branch distributor environments, and home offices. Each one of these environments includes multiple wireless and wired devices, including APs, gateways, switches, and WANs. Each one of these devices is sending telemetry to the cloud. The advantage of having all these devices sending telemetry jointly to the cloud is we could do modeling across multiple environments, multiple devices, and do end-to-end root causing. In the cloud, we train and deploy models. These models generate user visible outcomes or even self-correcting outcomes or outcomes that go to improve our tech or our product. And that's what we call AIOps. And all this is done under the AIOps, under the secure environment. So starting to roll up the sleeves, one of the most important parts of good AIOps is good data. And by good data, I mean the quality, granularity, adaptability, and also the volume and diversity of the data. On the quality of the data, first of all, we need to get telemetry from all devices and clients. And this includes things like state, configs, stats, metrics, and events. In our case, we do intelligent edge pre-processing because we don't want to send all the data available at the end devices because this will just overwhelm and not add a lot of value. We need, for some things, we just need low frequency, but for some things we need high frequency and high time granularity. So we do, it's both rich and diverse. And again, having this unified infrastructure and the cloud benefit, we actually have clusters around the world. So we have a very diverse set of devices. And on the right side, we show some of the volumes of the data sets that we have. We have over 1 million network infrastructure devices. That includes APs, switches, gateways. And from these, we collect all features. And here's just an example, a list of features. So far, we have collected fingerprint information from 55 million end client devices. These are your iPhones, your cameras, your laptops. And then we have also over 65,000 customers. So this gives us a lot of vertical diversity, everything from universities to enterprises to fast food chains, stadiums. And when you get lots of customers, in addition to getting lots of environments, a lot of device types, you get a lot of diversity in the features they've enabled and on the configs they've actually played with. So from all this diverse set of data, and all these customers trying different things, we could figure out what is best of breed and what is best for every customer. Okay, so
quick question in there.
Yes.
The 65,000 customer base you're talking about, you collect data from all of them for AIOps, or you're talking about a potential there?
No, that's from all of them currently. That's not potential, that's actual customers that we are collecting data from.
For the AIOps?
Yes.
Okay.
Yes, and I'll talk a little bit later about all these environment classification and config optimization that's learning from all these devices and all these customers. So again,
I have a question as well, just because this is a lot of information you're collecting. Is this an opt-in type process for the customers? Because I'm sure there could be some potential privacy concerns about collecting all this data. And maybe you deal with this later in the presentation, but I'm just curious, like, how does this work from a privacy and protecting your customers and their unique data perspective?
So we definitely protect individual customers' data. And even though the jobs are multi-tenant, the PII information is not leaking between the customers. And there's other people that actually work on the secure part of the angle. I'm mostly on the modeling. But yes, I'll talk later about how the models could learn interesting things about the underlying behavior without knowing anything about the clients themselves, the individual 55 million devices.
Okay, thanks.
Okay, so on this slide, the left side is all the data input we've been talking about quickly, and the right side are all the customer visible, actionable insights. And in the middle are all the machine learning models we build that connect the input to the customers. Just to get an idea of the size of the data that we're actually shipping to the cloud, each device is only sending about 3 kilobits per second, thanks to our intelligent smart telemetry that is actually looking for interesting events and is actually compressing and all those things. But once you have 1 million devices, it's about 32 terabytes per day that we're actually processing. So some flavors of the toolbox of machine learning models that we use is, first of all, these environment classifications, one of the base of a lot of things we do. Basically, 65,000 customers, 1 million APs, we cannot mix them all. We cannot get a service provider in Mexico and compare it against a library in Ohio State Union. So what we do is we immediately break up all these environments based on Wi-Fi environmental features. So we have these peer groups. In our case, we have 25 peer groups. Each one of these peer groups creates baselines of what's normal behavior for this peer group. From these peer groups baselines, we could actually detect which devices or which clients are actually anomalous. So we could create some metrics around anomalous events, which we'll pre-process and aggregate for root causing. We also could actually provide recommendations, as I was describing earlier, because we have all these customers trying different features and different configurations. For the same environmental class, we could figure out best of breed, what is the best configuration that optimizes every specific environment. And of course, if this is not a static thing you do once and then just run, all these models are continuously adapting. And for many reasons. One is because we constantly have new clients. We often have new geos. We deploy new APs. We deploy new software. Sometimes the software themselves trigger anomalies that we actually have to go and fix. And what are customer visible insights? We don't actually supply, you could, but we don't actually supply every single anomaly to the end customer. What we do is we try to aggregate through clustering techniques all these anomalies into big modes with root cause of what is the likely cause of this anomaly. Another type of AIOps are these what we call config recommendations, some of which are open loop, meaning the customer gets to see the data and make the decision. Others are closed loop. We could automatically change the network configurations. Right now we have about 10 different configuration knobs that we could actually adjust based on all this peer grouping and modeling optimization. And these include things like optimizing the transmit power for 2 gigahertz, 5 gigahertz, the SNRs for which we allow clients to get onto APs, the list of channels that are optimal for your environment, then other things around PoEs and dynamic path selection for if you have a WAN with more than one, you have a gateway with more than one output. And also, we also provide things around measuring and monitoring. So if you just want to see how you're behaving relative to peers, so it not be anomalous, but you want to see just how you're doing. So you could actually measure against, we have different monitoring and measuring approaches. And the baselines include your peers, your own other sites, and versus time. And again, talking about insights, we generate over a few million low-level insights per day across all our platform. But these get intelligently clustered and raised only in the thousands per day, but this is across 65,000 clients. On the average, a big customer sees a handful of insights, and later I'll actually show an example of a real customer and some of the things they could see. So this is another view of the AIOps model hierarchy. And again, on the left side is the data, and the right side are the outcomes. Sorry?
No, I'm curious about, the approach you are taking here. I mean, there is a team in HPE that is very focused on AI since probably forever, since Nimble Storage, I mean, InfoSight, okay? And they started collecting data and building models around infrastructure for a long time. You started from scratch with all this work you are doing, or you are taking advantage of some of their experience, knowledge, tools that they developed over the years?
No, this was started from scratch based on another acquisition called Rasa, which is started being more wireless optimization centric and then grew into the wire space. But it's an independent effort, yes.
Okay, and do you see, I mean, still today, I see Aruba as almost a different company from HPE from the outside. The orange instead of the green just, probably say something. And do you see an effort in the long term to consolidate the two approaches in a single large AIOps infrastructure platform? or is it too early, too far from each other?
No, you are correct. We are going towards a unified platform. Yes.
Okay, thank you very much.
Okay, so I'd like to address some of the questions that came up earlier. So again, this is another view of how the model hierarchy works and actually in practice. So left side is data, right side are use cases that are user actionable. And there was questions about all these million of devices, 50 million end user devices, all this data going to a few clusters around the world, and then building models on a supercluster that collects all these. First of all, this data that's used to build models is anonymized. We don't use PII information to build models of what is the optimal transfer power for APs for a specific environment. We don't need to have usernames to figure out what is the optimal SNR for which you let users get into your site. What if you have a distributed environment? We do have device type classifiers that use fingerprints around the devices, but the model itself doesn't collect the end user names of which ranges of MAC addresses are which device type. It just gets the fingerprints, and then the model output is actually ranges of probabilities of where this range is most likely to be an iPhone and this thing is most likely to be a Samsung TV. So there's no leakage of your iPhone leaking to some other model that would actually be visible for some other customer. But we do have use cases, in addition to these use cases around root causing big problems or recommending configurations that would optimize your application performance, or some things that automatically disable APs to save power. There's actually use cases that our customers want around troubleshooting individual devices. And this is more like somebody calling in saying my Wi-Fi does not work. So under those more reactive cases, which I don't describe, many customers want to be able to type in a username and search for the Wi-Fi performance metrics. So for the end customer for that specific site, they could search by username. Some of our end customers have asked us to not get their level 1 support, level 2 support access to usernames, and then we would hash those. But for most, they want to be able to find specific problems for individual devices in addition to these more network-wide use case optimization techniques. But one thing that I have not talked about so far is, okay, so the bottom left shows all the anonymized data that goes to low-level models. These low-level models generate outputs that enrich higher-level models. And I'll give 2 examples of a low-level model and a high-level model later of an actual model that's deployed in 1 million network infrastructure devices. In addition to the anonymized peer data, there's also telemetry, and there's also support cases from our TAC organization that we use in this AIOps thing. Because in addition to the statistics and events and configs that are coming from the network infrastructure and all the clients interacting with this network infrastructure devices, we have people running networks calling our support saying we have a specific list of problems. There's some debugging happening, and there's a actual labeling of what actually went wrong. So this is actually a good example of trained data, because most of the other data is unsupervised. So we have enabled some supervised cases by using our TAC data. And then once these cases get resolved, we could automate these TAC resolved cases and deploy them to peers that probably haven't realized the problem is there, or preempt the problem by improving the product in the next release. So the bottom right also shows that. Not all model outputs are actually user actionable. Some of these high-level models produce outcomes that actually the root cause is a Qualcomm or Broadcom chipset issue. So there's where we could actually contact them. We have big data volumes. We could actually drive them to fix the problem very quickly. We could quickly find the workarounds for a software patch that we could deploy quickly. So this is a first example of an actual model that we have in production. In this case is the environment classifier. This is an example, low-level model example. So the type of inputs this takes, this takes about 15 inputs. So it's a 15-dimensional clustering algorithm that takes a lot of Wi-Fi environmental features, things like what is the AP's capability, how well the Wi-Fi signals propagate in your environment, what are the client device types, and actually there's a separate model that actually determines the client device type, which is another low-level model, all type of signal strengths to the APs, the motion of the clients, what type of applications they're running, what type of volumes they're running, and then we characterize all our it's probably about 900,000 APs currently under management across the world into these 25 classes. So then we could further do all the baselining, anomaly detection, and configure recommendation based on these classes. And of course, I can now show you a clustering in a 15-dimensional space, but the best I could do right now is project those 15 dimensions into 2 dimensions using nonlinear t-SNE projection, which is shown here in the bottom right. In each color, it's actually each dot is a customer site. For example, if you think about a fast food chain, they may have 3,000 sites. They'll have 3,000 dots in this plot. And the coloring is a cluster label. And you can see there's about 15 colors here because there's other 10 has been put into a different class of, there's a big site class and small class size, and there's 15 plus 10. So there's only 15 here shown. And basically what you do is once you get one site you want to optimize, you figure out where in this 15-dimensional space, which cluster they line up. We figure out which model, whether it's anomaly baseline or whether it's a config optimization based on peers, based on features they enabled, what is the optimal configuration for that, for your site. Okay, so this one is an example of actually a high-level.
Got a quick question on a previous slide.
Yes.
So when you get a low-level model, they seem to be generally created out of data across the board, more of across all your customers. And then you mix that up with your customer data to create a high-level models. And those models, what you create, the machine learning models, are they private to the specific customer, or do you take intrinsic value and some of the model capabilities from the high level and share it across with the other models too? Because at that level, it's not data, it's more of a model. Do you share them across?
Yes, no? Of course. Yes, I didn't explain it very well. So the anonymized peer data will be the 1 million devices. The black lines are the training of those bubbles, where each one of those bubbles is a model. Then you create for each customer instance, your data. The green line will be the inference of the model created across all the customers. Yes. So those models are shared. So each one of those models, the environment classifier is working across 1 million devices, and all the other 1 million devices, when they go check the model, they see what class they are in and what is the optimal configuration for that class. It's shared. But these models don't have information about usernames or where they've been or how long or who they've been close to.
Well, then the secondary question that I would ask would be essentially a model is nothing but sort of a snapshot or minutia of the underlying data. So if my data as a customer is shared with other customers, what kind of protection I have about my data model that's being built based on my data?
So when we're trying to optimize what is the settings you should configure your APs to optimize your performance, and the model basically is, think about this black box that checks for your environment and your payload, what is the optimal settings. That black box has learned from 1 million other devices, what is the optimal settings. What information about an individual customer is latent in that model. So saying Home Depot, Lowe's, KFC, Verizon, university campuses, all contributing to this high-level model that says, if you set the power to 12 dBs, you get an average of 75 megabits. If you set it to thing, it gets you 110 megabits. The model is actually a mapping between inputs about your environment, knobs choices, and what is the performance you would get based on that. What could somebody learn from that model about your competitors? That's your question? But first of all, we don't actually give the model to anywhere. We just do what the green arrows say, which is an individual customer gets to pull that model and see what's the optimal config settings for their environment. They're going to basically set knobs of how many dBs to set this, how many dBs to set that, turn on this thing, turn off that thing. That's what they see.
Yeah, okay, no, that's one. And also I just realized that your machine learning models that you're creating out of that is more towards the network traffic than some of the other AI vendors, which goes towards the digital experience and also at the application level. So I just realized that. Never mind.
So we're not collecting data packets. We're just counting the volume of bytes those data values.
Right.
So let's say you're doing a terabyte of Netflix in this site. And what's the optimal settings to make this run 20% faster? But we're not saying who is doing what. We're not keeping per username how much Zoom they're doing or how much Skype, or it's basically aggregated stats across the user population in your sites, creating a model of what's the network config settings that'll optimize the experience.
Okay.
Gotcha. And given that there's so much pooling, for example, on this plot on the bottom right, each dot is a site. Usually an environment class has thousands of sites across tens of customers. And we actually make sure that no cluster is too small, meaning in the clustering algorithm, if some clusters come out too small, we'll actually aggregate it with clusters nearby to make sure that there's not only 2 customers in one cluster. Because if there was only 2 customers in one cluster, maybe one customer could see what the other customer is doing, right? Because you have your knobs, there's some other knobs that you got recommended, and it was only 2 customers, but we don't actually publish what class you're in. We don't say who else is in the class. And we actually make sure each cluster has enough samples so it's statistically significant, and also so it's more anonymized. I don't think there's any leaking of configs across tenants here.
And the model management is done by you, or you share that model with the customer so they can fine tune it?
No, they just get what's in this top right, the green arrows, which tells them how to configure the network to optimize the experience, and monitoring tools to tell them what the current experience is and what you would get if you made the change.
Okay, so you just make the recommendations to them on how to do that. You don't share the models, or you don't let them train it?
No, we don't let them train them. We don't tell them what color they are in this space. We don't tell them who else is in that yellow patch. And we don't tell them what they're doing. We just tell them, for the people in the yellow patch, this is the optimal configuration to get the best Zoom experience. And we make sure
then the next question would be, do you also have a means and ways to automate? If I'm a customer, and then if you are giving me insights suggesting you got to tune your network this way, if the customer is okay with that, are you able to auto tune based on your model outputs?
Yes.
Or do you leave it to the customer?
Yes. So right now there's no apply button yet, but we're in the process of closing the loop, where the customer could just look at the recommendation, just press opt-in, and then all future things will automatically happen versus having to review. But a lot of network operators right now, at least the bigger ones, like to see the machine outcome before they actually hit OK. Just like self-driving cars like to show you what's going on the road, just in case you don't trust the classifier and you want to hold on to the steering wheel. Okay, this is another example, and this is actually a customer visible. This thing on the right is actually a screenshot from the Central Cloud Visible user. So for this specific customer, they had 3 insights. There's the high number of DNS connection failures, this access point transmit power recommendation, and this is outdoor clients impacting Wi-Fi performance. Those are the 3 high-level insights that this customer got recommended. The one has been clicked is the 3rd one, the one that's been opened. And basically what this model does is trying to reduce outdoor clients walking by close to indoor access points and connecting to them. And this is a very important use case for distributed environments. We have a small site with a handful of APs and people walking in front of your store and constantly connecting to your APs and affecting the people inside or running out of AID links for that AP. So basically the underlying model, the low-level model for this, is actually an indoor-outdoor classifier, which is based on about 15 features of how the end user devices interact with the APs that are indoor the store. And based on this classifier, every minute we could tell if the client actually has walked into your store or just walking by your store. And this tells you how to, the reason is basically clients connecting with lower SNR to your store, and the recommendations to change these 2 knobs. We give you a little data of how many clients have connected. This is actually from a fast food chain that has thousands of sites across the world. And this is the number of outdoor clients that have connected to APs inside the fast food chain over a day. And the distribution on the right shows you the light blue is the clients that are actually inside your store, and the dark blue is the clients that are actually outside the store, and how to configure your network so you don't actually have to service the people that are in that dark blue thing that actually just walking by just in the parking lot. So here's an example of a model that actually has been trained across all tenants. You would apply it. This model is actually specific to the environment. It's not the same thing to train this thing for a library than to train this for a fast food chain. So the model is specific to the environment, and then it tells you how to configure your APs so that people outside do not connect to your APs. And just to summarize, why Aruba? We have a complete AIOps solution driven by the cloud. This AIOps includes wireless and wired devices. We have a rich data set of over 1 million network devices. Because we have rich, granular, and diverse verticals, we could do all these peer comparison-based models. And we have a unique way of streaming smart telemetry to the cloud that enables all of these. So I don't know how we're doing with time and questions.
Hey, I had a question, Jose. For the recommendations, what all vendors' equipment does that work with?
Sorry?
You said that it will provide recommendations. Is that just for HPE equipment, or is it for other vendors as well?
This is only for HPE equipment, yes.